It's time for Maths with Mr. Thomas.
Yippee-ki-yay! Chapter 11, lesson number 2, the equation of a line in parametric form. Now, if you remember in the first lesson, we were writing our equation of the line in 3D in general symmetric form, which was this. We had x take away x1 over a equal to y take away y1 over b equal to z take away z1 over c. And they were all equal, and they were equal to some scalar parameter, t. X, y, and z stayed as x, y, z, but x1, y1, and z1 were the coordinates of the point, x1, y1, z1, and a, b, and c were the components of a vector, which was in the direction of the line. If we have then the x take away x1 over a, well, we know that's equal to t. If we rearrange this, though, we could get x equals. So if we multiply both sides by a, we'd have x take away x1 equals at. And then if we add our x1 to both sides, well, we can say that x and its own would equal the x1 plus at. Doing the same with y take away y1 over b. Again, that's equal to t. If we rearrange that, multiply both sides by b, so we'd have y take away y1 equals bt. And if we add y1 to both sides, then we would have y equals, and on the other side we'd have our y1 plus our bt. And finally, with z take away z1 over c equals t, we can rearrange that to say that z would equal, multiply both sides by c, so we'd have ct on the other side, and then add z1 to both sides as well, so z would be equal to z1 plus ct. You can see that what we have done is we have rearranged this and we have expressed our x, y, and our z in terms of the parameter t. And if we do that, it is known as expressing the equation of the line in parametric form. So that is when you will have x equals, y equals, and z equals, and on the other side it will be in terms of the parameter t. Let's look at some examples. So example 1, a line passes through point A with coordinates 3, negative 2, 5, and is parallel to the vector 2i plus 4j take away k. Find the equation of the line in parametric form. So what you might want to do first of all is think back to symmetric form. Remember, for your symmetric form, you would have x, y, and z. You're subtracting the coordinates of the point, so we'd be taking away the 3, the negative 2, and 5, and we're going to be dividing them by the components of the vector, so the 2, the 4, and the negative 1. So it may help, if you have to write the equation of a line in parametric form, to first of all write it in symmetric form. So x take away x1 over a will be x take away, well, we're taking away the coordinates of the point, so it'll be take away 3 over the 2. That will be equal to, well, that's equal to y take away negative 2, which is going to become y plus 2 over, and then the vector, we've got 4. And that will be equal to z take away, taking away 5, and we're dividing that by, looking at the vector, we're getting negative 1. So we have x take away 3 over 2, y plus 2 over 4, and z take away 5 over negative 1. And they are all equal, and again, they're equal to some scalar parameter t. If we're asked to express it in parametric form, which we are, then all we have to do is rearrange this, so we get x equals, y equals, and z equals, and we want them all in terms of t. So, for x, what would x be equal to? Olivia? Perfect. Well, we know that x take away 3 over 2 is equal to t. Multiply both sides by 2, so we'd have x take away 3 equals 2t, and then if you add on 3 to both sides, we can say that x would equal the 2t plus 3. Looking here with the y, add 2 over 4, well, again, that's equal to t. Multiply both of them by 4, so we'd have y plus 2 equals 4t. Take away the 2, and y would equal 4t, take away 2. And with z, take away 5 over negative 1 equals t. If you multiply both sides by negative 1, then you would have z take away 5 equals negative t. And if you add 5 to both sides, you would have z equals the negative t plus 5. And that is your answer. That is the equation of the line in parametric form. Woo! Example 2, find in parametric form the equation of the line passing through the points A with coordinates 1, negative 2, negative 1, and point B with coordinates 2, 3, 1. So, how do we go about doing this? Brilliant. The first thing we need to know is a vector. We need the direction vector. To write the equation of the line in symmetric form, well, you need to know a point and you need to know the direction vector. The points, well, we've got two of them. We are spoilt for choice, but you also need to know the direction vector. How do we go about getting the direction vector? What do we do, Lily? Brilliant. We can just work out the vector AB. We know that AB is going to be in the direction of the line. So, vector AB is a vector in the direction of the line. So, to work out AB, how do you do that? Well, AB is going to be B take away A. So we'd have the 2 take away 1, we'd have 3 take away -2, and we'd have 1 take away -1. If you work that out, then it means the components for vector AB would be 1, 5, and 2. Once again, in order to write our equation in parametric form, it's sometimes easier writing it in symmetric form first of all. So with symmetric form, again, you need to know a point, you need to know the direction vector. We've got this direction vector here, 1, 5, 2, and the points, we have two of them. Just pick one of the points, it does not matter which one you use, I'm just going to use point A. So, in symmetric form, we would have x take away x1 over a. x1 is going to be the x coordinate of the point, which will be 1, so we'd have x take away 1 over, and we're dividing that by the component from the vector, so we divide that by 1. That will be equal to y take away y1 over b will be y take away -2, which becomes y plus 2, over the 5. And that will equal z take away z1 over c will be z take away this -1. So in other words, z plus 1 over, and then from the vector we've got 2. And that will equal t. That is the equation in symmetric form. We are asked for a parametric, so we need to rewrite it in the form of x equals, y equals, and z equals. So take just the x take away 1 over 1 equals t. Multiply both sides by 1, and you'd have as x take away 1 equals t. Add 1 to both sides and you'd have x equals t plus 1. To get y on its own, well, y add 2 over 5 is equal to t. So multiply both sides by 5, so y add 2 equals 5t, and then take 2 from both sides. So y would equal 5t, take away 2. And z plus 1 over 2 equals t, multiply both sides by 2, so z add 1 equals 2t. Subtract 1 from both sides and z would equal the 2t, take away 1. So that is the equation of the line in parametric form. Example 3, the equation of a line in parametric form is x equals 2t add 3, y equals t take away 4, and z equals -3t plus 1. Find the equation of the line in symmetric form. So we know we have x equals our 2t plus 3. If we are rewriting that in symmetric form, well, remember for the symmetric form we had x take away x1 over a equals t, and we had y take away y1 over b equals t, and we had z take away z1 over c equals t. So we need to rewrite this in terms of t. So to do that, we would subtract 3 from both sides. So x take away 3 would equal 2t. That would give us what 2t is, and to get t, we'd then divide by 2. So we'd have the x take away 3 over 2. So x take away 3 over 2, well, you know that equals t. For y, we've got y equals t take away 4. Well, for that one, we would have to add 4 to both sides first of all. So we'd have y add 4 equals t, and really we've done that, but to write it as a fraction, we'd have the y plus 4, well, just over 1. And then that would equal t. And the z equals -3t plus 1. So to rearrange that and get t equals, we'd subtract 1 from both sides. So z take away 1 would equal -3t. And to get t in its own, you'd then divide by the -3. So we'd have the z take away 1 divided by -3, and that would equal t. Hence the equation of the line, if we're asked to write it in symmetric form, well, because they are all equal to t, they are all equal to one another. Perfect. So we can say that the x take away 3 over 2 is equal to that y plus 4 over 1, which is equal to the z take away 1 over -3. And that will be the equation of the line in symmetric form. So there are really 3 forms that we can write our equation in. If we know a point, x1, y1, z1 on a line, and a direction vector, ai plus bj plus ck, which is parallel to the line, and we can express the equation of the line in vector form. So you can express it just with the components like this. You can write it in symmetric form, or you can write it in parametric form. So there are three forms that you need to be familiar with. Try some of these questions on expressing the equation of a line in parametric form. Best of luck. Have fun.